Good morning. I want to talk about compiler's context within Jane. What is it that we're actually trying to accomplish when we write a compiler or something that builds applications? And that includes the complete technology of software development. So I'm on a change in our current software development technology, and I would like to show you that right here. First, we look at our current software development technology. What does it look like? What's it do for us? And how can we improve on it? First, we must understand what software is. Well, software is contained within a file that has hardware instructions. And there are very few hardware instructions. In effect, we have some math operations, add, multiply, and divide. We have conditionals, which we can check and compare whether it's less than or greater than or equal to or not equal or things like that. And then a jump. And a jump could be into a subroutine. And so that's our software development technology. We write those instructions. However, software is only concerned with those hardware instructions. That's our logic. We have to write in assembler, in effect. A high-level language is just a simplification of assembler, but it does identical things. We could either write an assembler or any of these so-called high-level languages. The only thing you're saving is a few keystrokes. Software logic that we write today has one purpose. So our software is an application. We write one application and it has one purpose. So for an operating system, it's simply to manage and run applications and access the hardware, or that's where we put it. Our source code that we write has, since it's one purpose, it has unique logic. And it's difficult and impossible to read. Our source code has limited access to our information and no security built in. It simply calls more software to generate security, but the physical hardware has no restrictions. And our source code has hard-coded data structures. So our data structures, let's say we have out there a name or something, which is stored in a few bytes of numbers. What those numbers represent is hard-coded in our source code. So the computer can't tell whether that byte or set of bytes represents anything other than a set of bits. And so we have to have source code to determine what our data structures are. And this simply locks out any representation or movement of our information out of that source code. And our applications are computer language dependent. So if I write in one system, in one compiler of a particular vendor of a particular version on a particular machine in a particular version, it goes on and on, that our application is very dependent upon changing technologies. And we have to generally use more than one language to build our applications now. One size does not fit all, and it's never complete. So when we write our applications, we expect this software developer to be a subject matter expert. He is not. You can say this is a particular application for a particular purpose, but everybody's purpose is different. So I, as a software developer, do not really create applications that are subject matter expertise, because I don't know what your job is. I can assume what your job is, but we don't. And so if we write Excel type of applications or word processing applications, what they've done is they've said, oh, this is generic enough. You have to model your environment to what we've decided you should work with. And those generally are watered down. Excel was limited to 64,000 rows. They bumped it up to 1 million, but if you get more than 1 million, maybe they'll bump it up to 2 million, so on and so on. And so every application has limits, restrictions, and ways of doing things that says this is the way you're going to do your job, period. And that is all of our applications, whether it's an operating system, compilers themselves, editors. Everything that we do on our computer is designed generally by one person who makes decisions for the rest of the world. And then what we get down to, sharing our information, we've decided that the only way to really do this is to have one. Okay, Autodesk says I will do it. They make AutoCAD. And they've decided, the world has decided, look, if everybody has AutoCAD, then we can share all of our files. That's what's happened. Microsoft has said the same thing. We will build you a window to display forms, or we will build something. And so they've gone in and said, we'll build an operating system, and everybody buys that, and then we can share, period. And the only way this really works is if there is only one. Oh, we have Unix, and so there again, we can only share on comparable Unix systems. And unfortunately, there's 15,000, seems like millions of versions of all the different versions of Linux, and all the different vendors and versions and dates and everything. And Google says we will make one search algorithm. And so everybody uses that because there's only one. Sure, there's other systems out there, and we've tried to make different browsers, but that doesn't work because no two people can ever design software identically. And yet we as users want an identical environment, no matter what browser we come up with. So we have so many compatibilities when we have two of anything. And this creates monopolies, which kills technology. So we come up with no source code or data. So all of our data structures are proprietary or fixed or unable to be shared effectively. Sure, we can force the sharing, but it's never 100% because no two people can produce software or data structures in identical manners because they're two different source codes. And so it's not shareable. To change our technology, what I want to do is I want to move everything I can out of our source code, because if it's in our source code, we have to rely on it to contain the information and knowledge that we want about our data structures without having source code. We don't get the source code. So we would like to have that information available to us independent of source code. And we want the source code to do logic. So we want all details about all data structures out of source code. We can put it in a neutral format that says here, any application can access your information, period. No ifs, ands, or buts. It's not in somebody's proprietary source code. It's your information, it's your data. Irrelevant if they sell you something and say, oh, this table, which I built, but unfortunately that doesn't work for us because those tables are locked up. We need to be able to see everything. And all those structures have to be accessible to my hardware. So we want to move all possible conditionals into scripts. So we want table-driven logic. So 99% of our applications run on lists of things. So if you have an editor, if I hit this key for this key or these combination of keys, it performs this action. Now those actions should be adjustable based upon your particular need. And compilers are the same way. I have these statements. Condition of those statements can be table driven. We'd like to get hardware validation. Currently, none of our hardware takes a byte, and the software, again, our logic is in our software, of what can be done with those particular bytes. But if we move some of this logic down, or validation down to the hardware, it says, oh, these 3 bytes are 17-bit number, or whatever we want to say, and let the hardware say, yes, I can add that number to that number, and we can validate that. Or this is a Boolean. No, I cannot add 2 Booleans together. It makes no sense. And so we get knowledgeable instructions at the hardware level. And then this gives us far, far superior software because we're validating it at the hardware that, yes, this operation can be done. Okay, and we want to move everything possible into the compiler. So we want the compiler to be as powerful as possible. And so what could we move there? We can get rid of all of our input and output and our data movement into the compiler. So we get rid of file reads and writes out of our source code. We need a place for all knowledge. If I have a image or some piece of knowledge and I have knowledge about that, I'd like some place to put that. Oh, here's an image. Okay, this is me and my wife on vacation last year, and make that universal and keep it with the image, not external. This externalizing of knowledge is killing it. Oh, it works here, but it doesn't work there. We'd like to have with access to all common knowledge. So we have lists of boys' names, list of animals, list of scientific names, list of chemicals, list of math equations, math. We probably have, we have an infinite amount of space. We simply need to be able to access that within our program, which we're going to do anyway. Why not have it available through the compiler? Partition. We need vertical and horizontal partitioning of our information. Just about every piece of information we have needs to be partitioned in one way or another. Books are partitioned by chapters, pages, and so we need those kinds of partitions. Other information is partitioned by date or month or year, or other partitions could be by division or by position or by thousands of other things. When we partition, there's a whole lot of logic that goes in on that could be done for us, which is, oh, let's say I took my source code and I partitioned it by function, but I want to edit it as a complete. So I'd like to be able to say, yes, they're physically. And we want visualization of everything, from the hardware to files to the content of the file, to the context of the file, to the logic that was applied to the file, to the purpose of the information, and to the history. When was it created? When was it last modified? And when I say everything, I'm talking about everything from the hardware all the way up to every bit on that, let's say, disk drive. So we want access to all hardware and be able to use it and control it. So we want access and control of all information. So every binary structure and script we want access to and be able to use it. All security. We want security at the compiler level for our hardware. Ensure proper addressing scheme. Memory security, network security, all of these things should be done at the hardware level. We can't do it with our current technology. No, I'm not saying that. I'm just saying that we'd like to put in for our things that are possible units, physics, everything we know about physics or chemistry, or Windows forms, and we need context-sensitive logic so that as the context changes, the logic changes. And this is all done by the compiler. I want to get everything that the human's doing into the machine and make it extremely flexible by the user and by the developer and minimize their work. We want long-term and short-term memory. And we want all scripting languages to be accessible and used. And we want access to all binary structures. Every binary structure on a hard drive, where it's created or read off of the internet. Any binary or text structure is basically what I'm saying, and making them all application independent. And we do that through the compiler. We want data style completeness. Right now we have we have uppercase and lowercase. That's it. We did that through our fonts. That was kind of a byproduct of how we did fonts, and so we've kind of used it for the last 80 years inside the data structures, accessible and maintainable by the compiler. And this, so you have text, and that has styles. It has colors and things. You have graphics with the color of the line and the fill styles and all those, and all of that we want to be inside the data structures themselves, not external. So we want intelligent information, is all I'm saying. Information, we really want to concentrate on our information. The information is this: where did it come from, who created it, how was it derived? And so we want all knowledge to be contained inside of each and every data structure. And we want logic, and then we want the logic to be data independent. So we want to separate logic by action. More of our logic is information. This is how you do something. It's the verbs we have our data, which is, we can say they're nouns. Logic by action, we have logic, let's say, that is controlled from scripts. Logic that creates data structures, and then we have logic that modifies data structures, and then we have logic that uses data structures. And these are spread out and intermixed in our source code, where we can barely find them or manipulate them, and we use them once, and this is where all of our hard-coded data structures reside, and we want to take that out. But yet we want to isolate the logic so that we can control each of these and know what's going on. So information law, for every piece of knowledge in there, every piece of information, we want a qualified cast value detail. So a cast is, we cast information. We have a set of bytes in a file. So we cast this as a file packet, or whatever you want to call it. We want to know all the details about that packet, and we want it kept inside every data structure. So generally it has a name. This is a table. We might have a permanent location where this data will reside, or we would have a data structure which is saying here's a DLL, and it's got 13 or 20 substructures, and so each of those are described, the logic necessary to import and export these data structures. We want to know the purpose of the information, maybe the accuracy, and we want to know how was this information derived? Was it put in by humans? Was it a sublist of an employee table? And we want to know the partitioning structures, which is again the page or the chapter, by the year, the month, whether it's paid or not paid, all these partitioning structures, we want to take advantage of. And this is speed. This is pure speed. If I can have better access to my information without me working for it, that's what we want in our information knowledge. Then we want a list of alternate cast value names, which is, I have a file, and let's say it's casted, which is a set of bytes or bits, and then we could cast that as a carriage return, line feed, UTF-8 text file, but that text file might be cast as a CSV or DXF or whatever it is, and then so that we can cast it between all of these different things that it actually represents to somebody, to some application. We don't know what the application for the data actually is going to be used as, but if the data itself knows what it can or can't be, that would be nice. And then we also want to know who created it or modified it, and the what, the where, and the why, and when, and how. Logic and external control. A cast values logic units only have external control. When we write our logic now in our source code, the logic itself tries to control itself. But what I'm finding is that we can't really control without a whole lot of conditionals and a whole lot of calling of external references that don't apply to the logic. So let's say I'm drawing a DXF file. For some reason it wants to go out and get another file. Drawing the DXF file, DXF is an AutoCAD drawing graphic. The logic of drawing should only be concerned with drawing. And anything that modifies that or changes that should be external. We do it internally now, way too often. And that causes internal logic dependencies, and it's the internal logic dependencies that we're trying to get rid of. And so we want no internal deterministic logic. We want static and dynamic access to logic and data. Currently, compilers, we have pretty much static access without writing special code. Generally only comes in, we expect it to be in some file. Our compilers are current so-called high-level languages simply give you a read and write, and you have to go out and say, get it in, reformat it, and do all this work. We should let the compiler do that. Access, we want the compiler to have executable statements. So it may say, pull that file in, but all the lines into an array, or it's a CSV, create records of all the columns, and so on and so on. So we can put that in directly into the compiler, and it can load the data as part of the compiler. Because we may have a table we have all these code tables. We probably have more code tables than anything else. These are the divisions, these are the companies. And all those code tables, we just write thousands and thousands of little scripts that says, go get it, go reformat it, go do this, go validate it, pop it up in a form, and so on and so on. And that can all. And so most of our user interface applications are simply code tables, as much as possible. So we have text that we'd like to include into our code, into our application directly. Either statically, so it says, go ahead and pull it in, or dynamically say, when he accesses it, go get it at that time. Static means that the compiler goes ahead and pulls it in and makes it part of the application. Dynamic says only when he references it do you call it in. We want to include all binary structures. So the system, every binary structure has its own format and any special logic already attached to it. So these can be included directly into the compiler, statically or dynamically. And then we have all logic and data access is automatic. All of this we never see. So then we also want qualifiable data and logic. I only want 10 random boys' names. And we want it detachable. So once we access something, we'd like to sometimes get rid of it. I just did this file and it's 10 terabytes. Let me free up those resources and load in the next file. So we have LR and syntax compilers inside Django. Our current technology compilers, most of these compilers use LR, which is left-right, one look-ahead compilers, the Dragon book. And this technology uses keywords. So all of our current compilers, or most of our compilers, use keywords. And that's really irritating because you can't use one of those keywords in your application. And it's limited to most of our compilers have about 6 or 8 statements. That's it. We have a loop and an assignment and some declaration statements and a conditional and a brand, variations of that. But Fortran, I think, has 6 statements, and C has about 8 maybe. So it's very, very limited in how we write our applications because we're writing hardware. It has very limited syntax reference. It basically has a quoted text. So it's either a quoted text or single word variables, or it's a number. So we have an integer format, a decimal format, and an exponent format, hex, octal, and binary, and that's it. Everything else, if we have a date or a URL or anything else, we as programmers have to use basically numbers or text or single words to describe what we're trying to say. And it has fixed logic, so whoever built the compiler, it's dead. That is your compiler. There's no changing it. You don't need a go-to statement, they say. I like a go-to statement. You don't want to put it in. Why not? Who cares? Nobody ever sees your code anyway. One-dimensional fonts and black and white text. This is our technology. We can Basically, we could have used the 1868 typewriter to write our program. I started out on a key punch. Write 1,000, 2,000 line card program, no slower and no faster than what we have now. And the printout looked identical to what we have now. So Cliff Code is a syntax compiler. Covers everything that our current technology compiler built on syntax. It says look for the word create. We build our syntax and simply tell the compiler what to do, and so we can build natural language syntaxes, and we're not restricted by keyword. We can have an infinite number of statements with complex content, meaning that we can talk about anything at all within our one statement. And the statements are user extendable. Particular application needs a particular syntax for their particular equipment or inventory. They can simply add the statement in the way they want to see it. It has infinite look ahead. LR approach only has one character, so I get if statement. I can look and see if there's an open paren next. It looks ahead one. In here, we could go through, we may go down 400 parts of the language, tokens if you will, and determine that's not the statement. Let me fail. Let me look for another statement that applies. Generally, we know how to optimize our statements. We can put in special characters and just to make it easier to do. And we can also include our existing compiler. Here starts Fortran, here ends Fortran. Cliff Code already has all the statements that those other statements, all the declarations, everything that every other compiler has. And we want n-dimensional fonts for math, music, diacritic, and n-dimensional. We may want 2 dimensions, which would satisfy math, but we'd also maybe want we want fully stylized text doc. The only style that we have on our text is whether it's upper or lower case. That's it. 1,000 text styles that we have, let's take advantage of them, and we want to put it in our document. And so this should all be done at the very fundamental structure of all of our documents. Thousands of other styles make that part of our font. Just don't give one number and say this is an A. I'd also like in the document, every document, I'd like to know if it's bold. And right now we have external references or special applications for all of our text styles and our font styles and our graphic styles and so on and so on. So let's eliminate that and put it into our documents themselves, just as we put in all the formats and structures, so we put all that in there. And we want complex scripting documents, so it's not just software or hardware instructions, or let's put in tables. If we want a table in our scripting document, let's put it in there. And that thing says, oh, here's a table, I'll put it in your code. Now, you referenced it as A, and so we can do that. And images, I want to put an image in my document, so I'm not having to put it over here in some other file. And with static and dynamic, we can say, yes, that's in another file maybe, but I wanted that in my source code because these fonts are always loaded. Why are we going out and reading them and doing all this other stuff? Just put it in where it's part of our memory map within our application. And we put in diagrams and music and dance and chemistry and physics and everything else within our every document that we create. And we want complete control by the user of their hardware. So we want no proprietary data structures. Everything right now is proprietary. Oh, we'll create your information, but we won't give you the format of it. Well, let's do away with that. We want complete access to all source code logic. I mean, it makes no sense not to have complete control of your hardware. So we need complete source code logic, access to the source code, and make it available. Complete access to every data structure. Back to every binary and every scripting language, I want access to it. Complete control to communication. So any communication that I have with a modem or a mouse or anything that's coming in or out of any device, any piece of hardware, every piece of hardware I want complete control and access to. And I want complete control of security. So this is my text document. I want to encrypt it with my system, not some predefined, oh, we will encode it. Our security doesn't work. And I'm not trusting anybody because I can't see what's going on. I have to see, and then I know, and this is all for, look, where are we going with our software? We're getting pushed further and further away from our own information, our own access, and then everybody wants to tax you and, oh, we'll build a better system for you, but it's my system. It's not yours. Why? You just bought a $500,000 piece of equipment. You don't have control, access to it. If those people go away or you just don't want them anymore, you should have complete access to all the hardware. Anyway. So complete control of all the hardware, every piece of hardware, every piece of logic that's contained within that piece of equipment that you bought. Complete access to all communications. First I had control of it, now I want access to it. Make sure I do have access to it. Which means if I have a TV set out there, I'd like to know what's going on with communications. It's going out and doing something, but I want to make sure what it's doing at all times. Because as we move further and further away from our own control, we're losing absolute control over our own information and security and privacy. So we want access to all our attached devices. So everything on my home network, anything that's going through communications, I want access to. Well, thank you for your time. Hopefully this helps. And until next time, the thing I want to do is I want to give everybody access to their own information. Have one computer system one computer software development system that eliminates as much work on the developer as possible. Give more and more control to the end user. This is my hardware. You put software on there. I want to know what it is. These things are trivial. Oh, I drew a line. Oh, that's nothing special. I'm sorry. There is nothing special on these systems. And if you do want to write something special, then I want to make sure that anything you put on there is not communicating to something I don't want you to communicate to. So yes, you can hide things, but I'm going to set up Jane so that it's restricted to certain instructions. So this piece of code can only execute these instructions. And since there is no I/O or anything else in the system, they have to go through Jane to accomplish anything. That's how we start building better and better systems. Reliable and no versioning. All right, until next time, thank you.